Example 3. A football player kicks a football 2 feet above the ground with an initial vertical velocity of 75 feet per second. The function h equals negative 16t squared plus 75t plus 2 represents the height h in feet of the football after t seconds. Letter A, find the height of the football each second after it is kicked. So in order to do this, I'm going to create a table. Over here, we're going to have our time, which is our seconds. Over here, we're going to have our height, which is in feet. And time after each second it is kicked, I'm going to start at time 0, and then 1, 2, 3, 4, 5, 6, 7, because that's all I can fit, and we'll go from there and figure out what's happening. So at 0 seconds, we're going to come back to our function, and we're going to substitute in 0. So negative 16 times 0 squared plus 75 times 0 plus 2 is 2. Then we're going to do the same thing with 1. So negative 16 times 1 squared plus 75 times 1 plus 2, use your calculator, is 61. Negative 16 times 2 squared plus 75 times 2 plus 2. Sorry, I'm trying to get rid of that parenthesis. There we go. Is 88. Negative 16 times 3 squared plus 75 times 3 plus 2 is 83. Negative 16 times 4 squared plus 75 times 4 plus 2 is 46. And then negative 16 times 5 squared plus 75 times 5 plus 2 equals negative 23. At which point I'm going to go, wait a minute, this is representing height of a football. Height of a football can't be negative, so I'm not going to go any further because now I'm getting values that don't even matter. So before we move on to part B, technically part A is done. You've done your work. Let's just look at what's actually happening. So you kick a football at time 0. Then we went out to time 4 before things started getting weird. 1, 2, 3, 4. At time 1 second, you were at like 61. Then you went up to 88. Then you went down back to 83. Then you went down to 46. Then, okay, so you started at 2. You kicked the football. It kind of went up to 88-ish, and then it came back down. And I'm just going to write 88-ish, because I don't really know what the maximum was, but based on my table, it's 88. It could have gone a little bit more or a little bit less sometime in here. I don't know. But it went something like that, and then it came back and it landed on the ground. Now, part B says use the results of part A to estimate when the height of the football is 50 feet. Okay, well, if 88 is kind of up here, 50 is probably, I don't know, like somewhere in here. And I want to know when the football was 50 feet in the air. Well, that was maybe like right here, and maybe like right here. So let's go back and look at our values. Where in this set of values would 50 feet be? Well, the first one I'm seeing, well, here it was at 2, and then here it was at 61. So some point in time in there, it had to be at least 50 feet to get from 2 to 61. So between 0 and 1 second had to be. Well, so between 0 and 1, yep, and then it keeps going and it comes back down. So 61 to 88, 88 to 83, 83 to 46. In there, it crosses over 50 again. So between 3 and 4 seconds. Now again, that is just an estimate. Part C, using a graph after how many seconds is the football 50 feet above the ground? Well, we already have a graph up here, but based on the very rough sketch nature of this graph, I don't think it's going to tell us when exactly it's 50 feet above the ground. I know it's probably like 1 point something second and 3 point something second, but I don't know exactly when. So what I'm going to do, I'm going to look at my function. I want to know when the football is 50 feet above the ground. 50 feet is a height. So in my function, I'm going to come back to my h, and I'm going to substitute 50. So what we're going to be looking at is the equation 50 equals negative 16 t squared plus 75t plus 2. Now, in order to solve that, I have a couple options, but I'm going to stick with the idea of making this equal to 0, which is going to give me 0 equals negative 16 t squared plus 75 t minus 48. Now, once I have it equal to 0, I could factor it, but honestly, these are huge numbers and I don't want to factor it. So once I have it equal to 0, this is telling me find the zeros of the graph, which are also the x-intercepts. That's why we always like things to equal 0. So I'm going to grab my calculator. I'm going to type in negative 16t squared. Don't type t, it doesn't recognize it. So just switch your t's over to x's, plus 75x minus 48. Then, because I had set this equal to 0, we're looking for the zeros. My first 0, or x-intercept, is at 0.765. Well, didn't we say the first one was between 0 and 1 second? And then my next one is 3.923. Didn't we say the last one was between like 3 and 4 seconds? So t, based on my graph, is 765. Leave all the decimals, seconds, and t equals 3.923 seconds. Make sure you put a label on them. So after how many seconds is the football 50 feet above the ground? We had estimated between 0 and 1 second. Well, it's exactly at 0.765 seconds. And then we had estimated between 3 or 4 seconds, which is exactly 3.923 seconds.